All right, so we are learning about hyperbolas, and I am in class with 8th block. And here we go. We've got a picture of a hyperbola that's not all the way done. And as you notice, we were just talking about the ellipse and how it had 4 vertices. In the hyperbola, we just have 2. This one right here and this one right here. If you were to guess, what do you think the distance would be called from the center to one of these vertices? A, just like the ellipse. Perfect. And now we see, though, that already they told us we've got this little box here. And I'm going to tell you more about the box in a second. But since it's already here, let's talk about why that's 0, B. The B is always going to be the distance from the center to the top of this box. So kind of remember B and box. B always goes to the box, whether it's the distance from the top of the box to the bottom of the box or to the left and to the right. It's always going to have to do with the box. A is always going to be the distance from the center to each of these vertices. Okay? All right. As far as why do we need a box? Well, if you can imagine that we only knew the 2 vertices, and we were asked to draw the hyperbola, how would we know whether to make it a wide hyperbola, right, or a skinny hyperbola? So we have to have this box. It guides us. And guys, you have to stop talking. It's hard enough for me to do this. It's hard enough for me to try to make this a, thank you. So this box, what the box does, and we'll create this together, but what the box does is it allows us to put in the 2 asymptotes that lets us see how wide or how thin the hyperbola is going to be. So this type of hyperbola, which, remember how we talked about the laying down ellipse? Well, we have a laying down hyperbola and we have a standing up hyperbola too. This is a laying down, or this is one with the major axes, or the only axes actually, on the x-axis or parallel with the x-axis. We're going to have a corresponding formula for it. So we're going to have x squared. What do you think is going to go underneath x squared? A squared. We're also going to have a y squared. What do you think is going to go under the y squared? B squared. What do you think it's going to be equal to? 1. But the difference is there's a minus there. And that makes sense if you could use both your hands to kind of form an ellipse. You can see that maybe they're together because they're both positive and they like being around each other. But when they become negative, you know, you switch your hands out like that, and it looks like a hyperbola. Okay, so that's the formula, and I'm going to pause it so you guys can ask questions. Okay, and we are back. Before we get on to example 1, let's look at a hyperbola that's standing up real quickly. So in one of your blank spots, in the next blank spot or wherever you can fit it, because we're going to need both those blank spots. Wonder if, I'm just going to create one real quickly. Wonder if you saw a hyperbola that looked like that. What's different about it than the first one? Good. Yes, the A and B are going to be switched. So here's the deal with ellipses, they would be switched. So this one, they're not going to be switched. And I'll tell you what's going to happen. Because we see the hyperbola standing up and it's hugging the y-axis, we're going to put the y squared first. The a squared always stays in place. Okay, so this is opposite of the ellipse, right? With the ellipse, the x squared and y squared stayed in place and the a squared and b squared switched back and forth. But with a hyperbola, the a squared and b squared stay in place.
I suppose it's technically the same thing when if you're doing the
Yeah, this, yes and no. So we'll, yeah. So what do you think it's going to look like if we switch the center off? If we switch the center, in fact, let's go back to this one. If we were to switch a hyperbola who's hugging the x-axis, who's laying down, if we were to switch the center, instead of having this equation, what would we have? Yep. And same thing for this next one. If we switched the center and changed it and made it not be the origin, be careful, we're not going to write y minus h, right? We write y minus k. Have we talked about, oops, have we talked about how A, B, and C are connected? Have we? We haven't yet, have we?
No.
Okay. So yes, it's going to be cab, but I think you're going to like this one. I'm going to go back to the first one. A, B, and C. Let's see, do we even have C in here? Let's put C in here. C is always going to be on the inside of each of the hyperbolas. So they don't have a C in here. We're just going to say this is our C, and I'm sorry, that's our focus. That's our focus. So the distance from the center to the focus point, to each focus point, is going to be C. So go ahead and add that to your first. We're going back and forth, aren't we? Kind of all over the place. This will all settle in when we do our examples. All right, so we are going to have C squared equals A squared and B squared, but instead of a minus, we're going to have a plus. And the reason why is that, look, because we have this box, that's the parking spot for the cab. Finding a parking spot when you're driving a cab is a plus. It's a positive thing. That's right. That, Ethan, is why we draw the box, just so the cab can have a place to park.
So because the C is never inside the box.
Yes, the C is always inside this curve of the hyperbola, of each side of the hyperbola. Okay, let's do the first example because I think that's going to help a lot. And once again, do you have a question?
Yeah, just a quick. Does C always have to be on the same line?
Yes, yes. C and A, such a good question. C and A are always on the same line, always on the same line with the center. B is always going to be on the what's it called? The perpendicular, the line perpendicular to that. All right, let's do our first example. Write the equation in standard form of 4x squared minus 16y squared equals 64. I'm going to rewrite it here so I can work with it. Okay, what do you think we want to do first? Yep, divide by 64 because we need a 1 on the right side. So I'm going to divide everybody by 64. Okay, whether you choose to say, let's see, we can reduce it. I'm going to switch up into a color. 4 goes into 64 how many times? 16, thank you. And then 16 goes into 64 4 times. Okay. So whether you want to simplify in your head or actually if you put 4 over 64 into our nifty calculators with the fraction button and hit enter, it's going to give you 1 over 16. Obviously, we don't need to write the 1, but we're going to write the 16. All right, so let me stop here. So they gave us something that looked a little funny. Now it looks great. Wonder if they didn't tell us on the test what we were graphing. They just said, graph that. How would we know that this is a hyperbola? Good, because of the subtraction. That's the only thing that makes, yes. It says write it and then find the foci and vertices of the hyperbola. Let's graph it. Is there not a graph on yours?
here, but there is on the next.
Oh, okay, so then you know what? Let's not graph it. Let's go ahead and find the foci and the vertices. Okay, so the vertices, here's why I would like to graph it just a little bit. I know because it leads with an x squared, I'm going to, and because there are no h's and k's, my center is at 0. My a is 4, so I go over to 4, 1, 2, 3, 4, 1, 2, 3, 4. It just helps, even if you do a little stick graph, just to see where your vertices are located. So your vertices are located at 4, 0 and negative 4, 0. I would like it if you could get used to writing it that way. Instead of 4, comma 0, negative 4, 0, we write plus or minus 4, comma 0. And then it asks for the foci. And we know A, B, and C are related because we've got the cab, and it's a positive thing that there's a parking spot for it. So we know that A squared is 16, B squared is 4, so C is square root of 20, which is what, somewhere between 4 and 5, right? Well, they're not asking us to graph, but here's the important thing, just like what Ethan said. Ethan said, are C and A always on the same line? And that's an important thing to know, because if your A, if your vertex is at plus or minus 4, comma 0, what do you think your C, what do you think your foci is going to be located? Plus or minus root 20, comma 0. So that's an easy way to, you don't even have to think about it, because you know A and C, your vertices and your foci are going to be on the same line. So if, you know, depending where the 0 is for the vertice, that's where the 0 will be for the foci too.
A and B changed.
Yep. A and B stay the same. In ellipses, A and B switch back and forth. In ellipses, whoever's bigger is A. Yeah, and in hyperbolas, whoever comes first is A. A always stays. X and Y switches back and forth.
So B could be bigger than A.
Yes. Yep. Good. That's a good question. B could definitely be bigger than A. All right. Write an equation of the hyperbola whose foci are 0, negative 6, and 0, 6, and whose vertices are 0, negative 4, and 0, 4. Its center is at 0, 0. So do you have a graph on this one?
No.
Okay. So this is what I would do. I know I've got a fancy graph. Just do a straight up and down graph like this on your sheet, because when I'm given information and asked to write an equation, it makes it easier if I can just draw something. Okay. So my foci, I'm going to do that in blue. 0, negative 6, and 0, 6. Gosh, I wonder who's going to go first, x squared or y squared? Okay, all right. Some of you said the right answer, so we'll wait a second. And his vertices are 0, negative 4, and 0, 4. Okay. So, and its center, of course, is the origin. Okay. Is this a standing up hyperbola or a lying down hyperbola? It's a standing up. So it hugs the y-axis. So who comes first? Y squared. There's no h or k because the center is at 0, 0. So we'll have y squared over a squared always is the first one. Okay, so a is always the distance from the center to the vertex. In this case, it's 4. So 4 squared is 16, right? Then because we're in a hyperbola, we're going to use a minus. Then we're going to use an x squared because we don't have an h. And then do we know, we don't know what b is yet, do we? But we know it's going to equal 1. All right, how are A, B, and C related? We know that C is 6, so that's 36, and A squared is 16. Gosh, I feel like it's deja vu. Wasn't B the same thing, square root of 20? But you know what? Actually, we don't need to know B. We just need to know B squared. And we're done. All right, I'm going to pause so you guys can ask questions. Okay. Finally, we get to graph. All right, what does the 16 tell me? Good. So if A squared is 16, then A is 4. And A always, always represents the distance from the center to the major vertex, or both vertices. So I see that x squared. That tells me to go, my center is here because I don't have an h or k. So I go 4 to the right, 4 to the left. So far, so good. Then my b, since b squared is 9, and b is equal to 3, b always gives me my box, the other sides of my box, b for box. So here we'll go. We'll go up 3, 1, 2, 3, and down 3, 1, 2, 3, and we're going to make a box. You guys, I'm recording, but the notes are back there if you want the notes. So now, if we connect these four dots, it will make a triangle, and we want to make a box. So what we're looking at, these dots, are all the midpoints of the sides of the square. So when we make our box, we're going to keep that in mind. Each one of these points is the midpoint. Did I say square? Rectangle. Of this. Sometimes it might end up being a square, but in this case, it's a rectangle. So we use the knowledge of the 16 and the 9 to give us our 2 vertices and our box. And the box is really important because right now we don't know how wide our hyperbolas are going to be. So let's go ahead and find the diagonals of the box. Okay, that was not too good on my part. So I'm going to remind myself again, because x squared comes first, my hyperbola is going to be hugging the x-axis. So I'm going to use the asymptotes as a guide for how wide I should make my hyperbola. I think, and I said this to fifth block, there should be an exhibit at the Art Museum of different drawings of hyperbolas, especially if you use different colors. Hold on, I'm going to get questions in just a second. I'm going to turn off the thing. Okay, and we are done with that. I'm going to pause so you guys can ask questions. Okay, let's do example 4. So this is just like one of the earlier examples, except for we've got a graph. Okay, what are we going to do? Good. Divide by 36. The reason why we're dividing by 36 is because we need a 1 on the right side. So when we simplify, we got this. All right, so what I'm going to do is not talk, and I'm just going to graph, and you're going to graph, and we'll double check, and we'll come back with each other. I feel like we've done this graph. Was this one of the
first one?
This was the exact same one.
Pretty much. Yeah.
I thought it seemed the first one that we looked at.
That we
Yeah.
looked at, not that we graphed.
You have to draw the box. Is our graph complete without showing our foci? No, let's find the foci. All right, not pretty, but what is that? A little bigger than 9, and I'm sorry, a little bigger than 3 and smaller than 4. So I'm going to put it, put it right there.
Like 3.6.
Okay. Not aligned, so that's why those don't look right. All right, I'm going to pause so you guys can ask questions. Okay, identify the center, vertices, and foci of the hyperbola and sketch the graph. Yay, we have a different center than the origin. What is the center? Okay, -1, -2. See how it says identify the center or identify all of those things? That means you have to write them down like I'm doing. Something like this, perfect for the test. So here we go. Let's go ahead and graph the center. It's -1, -2. 4 tells me that the distance from my center to my vertex, can you stop talking? Thank you, is 2. Should I go 2 to the right or 2 up? Which way am I going for my vertices? 2 to the right, thank you. So 2 to the right and 2 to the left, because my x is leading. I know my vertices are on the axis that's parallel to the x-axis. So I've got that, and now I need to find the points to build my box, and the box comes from this number. If b squared is 1, then b is 1, and that means I'm going to find my box, up 1, down 1. Once again, these points are midpoints on for each side of the box. I'm going to connect them, and we make the box because we need those asymptotes to tell us how wide or how slim to make our hyperbola. Let's stop for a second because I moved ahead with the graphing, but I stopped with the identifying. So let's talk about the vertices. I would like you to be able to do this. See how our center is -1, -2? I'd like us to use our center and just write one point that represents both vertices. So here's what I'm going to ask you. What do these 3 points have in common? The x part of their coordinate point or the y part of their coordinate point? The y part, right? They're all down 2. So the x part is what's going to change. And how did the x change? We did plus or minus 2, okay, comma, -2. If you can understand this, then when we get to a square root, because sometimes a might be a square root, then you can write it like this. Otherwise, you could write it, or you could write it as what? -3, -2, and 1, -2, right? I want you to try to challenge yourself and do that. If you have questions on that, just hold on. When I stop the video, you guys can ask me. All right. I'm going to remind myself, because we've been away from it for a little bit, but I'm going to remind myself that it begins with an x. And so my hyperbola is going to go this way. But can you see, looking at the box and the asymptotes, that you might forget which way? Well, maybe not, because our vertices are right there. Okay. Are we done? No. Who are we missing? Yep, the 2 focus points, the 2 foci. So we'll have c squared equals a squared plus b squared. And we don't know our c, but we sure know that our a squared is 4 and our b squared is 1. So c is going to be square root of 5. Square root of 5 is a little bit bigger than 2. So it's a little bit more than 2 away from our center. Let's go 1, 2, and a little bit. 1, 2, and a little bit. This is where being able to write the 2 points as one really helps, because it's going to be easy to write our foci if we remember, and this is something going back to what Ethan said, if we can remember that the center, the vertices, and the foci are all located on the same line, then it's easy to write it. See how we mess with just the x right here? We're going to do the same thing for the foci. Our center started at -1, and the foci went plus or minus square root of 5, okay, comma, -2. Okay, I'm going to pause so you guys can ask me questions. Oh, gosh. All right, find the standard form of an equation. Oh, my gosh, look at this. What are we going to have to do? Yeah, we're going to have to complete the square. So the first thing we want to do is get organized. Let's bring our x terms together, leave a space, bring our y terms together, and kick out the 72. Okay, just like with those last few ellipse problems that we did, we can't get rid of both the 4 and the -9 by dividing through like we did with circles, where we could just get them both out by dividing through by the same number. So remember with the ellipses, what we did was we'd look at this part first, just the x's, and we'd say, let's factor out a 4. We'd factor out the 4. Okay, so we're just going to stop here and look at this part. Just like with the ellipses, we've done this before, last class, we're going to complete the square here. So we're going to say half of 6 is 3. So let's just go ahead and bring down the stuff that we're not doing anything with. So we're going to bring down the 3, but we have to remember what we're going to put here. So half of 6 is 3, 3 squared, 9. Now, did I just plop in a 9 on the left side? No, I plopped in a 36. 4 times 9 is 36. It's positive. I plopped in a 36. All right, let's do the same thing with the y. I'm going to factor out a -9, and I'm left with y squared minus 8y. I'm going to complete the square here. I'll bring down the -9. Half of 8 is 4. I'm going to bring down that minus sign. Oh, I made the same mistake before. When I factor out a -9, is that a negative 8y or a positive 8y? Positive 8y. I did the same thing in fifth block. All right. All right, so half of 8 is 4. 4 squared, 16. Did I plop a 16 in, or did I plop a -144? Okay.
No, 144.
No, you're multiplying by -9.
Yeah, 144.
Okay, so -144. All right, so somebody do the math. What is 72 plus 36 minus 144? -36. Okay. Oh, the plot thickens. What do we have to do? We already can tell there's an H and a K. Oh, look at all the things we're going to have to do. We're going to have to identify all those things and sketch it. So this would be a good candidate for the test. All right, so what's our next step? Yep, let's divide every term by -36, and something interesting happens, right? Our negative shows up there, right? That becomes positive. Can we leave it like that? No. We can't leave it like that. All right. I'm going to pause, and you guys can ask questions, and then we'll come back. All right, let's go ahead and graph it. What's our center?
-4, 3.
Okay, so I'm going to write it. Oh, that's right. Right? Don't make that mistake. H is still with the x, so our center is 3, -4. So let's identify it and graph it at the same time. So we'll do 3 and then down 4. Okay. What's our A? Our A is what? 2. And so am I going to go left and right 2, or am I going to go up and down 2? Up and down, because my Y is leading the formula. So I'll go up 2, down 2. A is always, always first. Yep. So then I'm going to do my box. Or, you know what, actually, let's write what these are. The vertices, I would like to encourage you to write them this way. I'm going to take my center. First of all, I'm going to ask you, Do these 3 points have the same x or the same y? The same x. So the y is different. So we're changing the y this time. And real easy to remember because we're leading with the y. We're going to be changing the y. So we'll have, hold on. So we're going to have this, -4 plus or minus 2. Okay, do I need to stop for questions? Almost hit the deadly button. Okay, so now we need to find the box. And our b is 3. So that means we'll go 3 to the right, 1, 2, 3. 3 to the left, 1, 2, 3. Does it ask us to identify the box points? No. So let's go ahead and make our box. Make our diagonals. And remind ourselves that we are drawing a hyperbola who hugs the y-axis. Are we done?
Yes.
No, what are we missing?
Well done.
That's right. Let's find the foci. Here we go. Our cab is positive that it's found a spot. That's another way you could think about it. So here we go. We know that a squared is 4, b squared is 9, so c is going to be square root of 13. So we'll write down our foci. Once again, we're changing. Yes, it's between 3 and 4, so we'll go out 1, 2, 3, and a little bit. I'm sorry, what am I doing? No. We're going to go this way. 1, 2, 3, and a little bit. And 1, 2, 3, and a little bit. Okay. What am I doing? Oh my goodness, I just made a mistake there. Let me see if I can go back. Okay, so from the center, 1, 2, 3, and a little bit. There we go. All right. So let's write them, the foci. Once again, we're going to mess with the y. So the 3 stands alone. We write the -4. And then what do we write? Plus or minus root 13. Okay. Now we're done. All right, I'm going to pause. All right, and our last one, find the standard form of the equation, vertices, foci, let's go. All right, you guys have a graph on this problem, right? Yeah. All right, so let's go ahead and plot 4, 1, 4, 9. Okay. Where's our center, guys?
4, 5.
4, 5. 1, 2, 3, 4, 5. Who leads, y or x? Y. So we'll have, if our center is 4, 5, we'll have y minus 5 squared minus x minus 4 squared. We're almost done. We also know the distance from the center to the each of the vertices is 1, 2, 3, 4. So 4 squared is 16. They also gave us the foci at 4, 0 and 4, 10. And so we know that C, the distance from the center to the foci, is 5, right? So we're going to go ahead and use our cab. It's so positive. It's a plus that he found his parking spot. So we'll have c squared is 25 equals 16 plus b squared. Can you see what b squared is going to be? We'll have 9, and so b is 3. Oh, well, we really don't care about b, do we? We just care about b squared. And that, my dear students, is it. That was much easier than the other ones. Okay, and then I don't want to end this because actually the next page shows the homework. So if you're listening to this, thanks for joining us and have fun with the homework.